Ah, bloody Lumi. Little Icelandic pony. Yeah? Came all the way from Finland or wherever the hell it snows sideways. Reckon she wanted to see the real Australia. Well, she bloody saw it all, right? First stop, Onslow. Hotter than Satan's armpit. She steps off the float and nearly melts into a puddle of horse soup. Poor things used to snowdrifts and glaciers. And here she's squinting through a heat haze thinking, what fresh hell is this? Couple of locals tried to tell her, yeah nah, this is a nice day, while she's looking for a fridge to live in. Then she heads down to Karratha, full of confidence, until her bloody 4x4 packs it in. Typical. You drive 1,000 k's through red dust, roofs, and road trains, and the bastard gives up right when you need it. So there she is, stuck in Karratha for a week, sweating through her mane, trying not to lose her marbles. Bloke at the servo says, mate, welcome to the Pilbara, where your car dies and your soul follows. Anyway, she finally gets the thing sorted and makes her way south. 1,500 clicks down to Manjimup. Trees everywhere. Proper cool breeze, smells like rain and eucalyptus instead of burnt tire and despair. She near cried, reckon. That first cold wind must have felt like heaven with a beer in it. She spent a few days wandering around, munching on green grass, meeting the locals. Nice folks down there, bit odd, but friendly enough. She even got herself a flash hat, a proper Akubra, Snowy River model. Said it made her look authentic. I told her, love, no hat on earth's gonna hide the fact you're a pony with a Finnish passport. Last stop, Perth, big smoke, traffic everywhere. People in suits who wouldn't know a hard day's work if it bit M on the arse. Still, she had a good time. Picked up a jar of Vegemite, bless her heart. Spread some on toast and nearly spat it through her nostrils. You people eat this on purpose, she says. Yep, we bloody do. Builds character. And then, just like that, she's off. Back to Finland. A Kubra on her head, 4x4 in pieces somewhere north of Geraldton, and a half-eaten jar of Vegemite in her pack. Reckon she'll be telling the reindeer back home all about the big Aussie outback, how she survived 40-degree heat, mechanical betrayal, and fermented yeast spread. Not bad for a little Icelandic pony, eh?
Hello! Well, I'm back. So, and the episodes will continue here as before. I'm back from my trip to Australia. It was quite a trip, actually. And yeah, what's missing from the picture? Huh? Of course. Yep. No trip to Australia would be complete without this stuff. And, as a matter in fact, I like it. Yeah. And now, special thanks to Max down there, 12,700 kilometers, about, I don't know, 8,000 miles there, in that direction. And yeah, I was visiting him in the very first day, and yeah, we had a short chat. And actually what I noticed is that, it's not that different in Australia than it is here in Finland. It's very much the same. Actually, it was in the Swan Valley in Perth, and this is the climate there is quite near what it is in Finland. A lot warmer, but otherwise the same. And yep, and of course it was Max Grant, and I will now put this sticker on there somewhere like that. And yeah, what then? Yeah, okay. So what we are going to do today, we are going to continue with this this holder and a retracting holder, which will be I don't know. Let's see what is coming. There is one piece that now should be done and one that should be finalized. So let us start with those. So now we shall align our scales to match so that this corner here in the back, which you probably won't see, is going to be origo. This operation here to align my scales is to drill and tap 2 M4 threads into this workpiece. So first step, let's align the x-axis. This is very sensitive. There you are. And now I zero here my scale. I cannot. Let's put it on 10 here. Yep, and then that's the X now, and I also need to set the fine scale to 0. Now I can align this with 1/100th of a millimeter accuracy, well, which I really doubt, but let's see. And then same thing for the Y. This is a lot easier as it's not as sensitive as the X direction. There you are. And then I will, and this is already aligned. Okay, so now I have aligned my scales. Okay. That's the first step of this thing. Next, let's change the tool to the actual drill. Yep, okay, now this drill bit has to be aligned according to the picture, and it has to be aligned. Let's see now. First of all, 5 millimeters from this edge inwards. So I first get it backwards, go back to 0. There you are. And then 5 millimeters. So that was 4 and that's 5. There you are. And then 14 millimeters from here, go past. Well, I need to go past the 0 because I need to compensate for the backslash. This milling machine has 0.4 millimeters backslash, so I need to be aware of that. That's now at the edge, I believe. Yeah, and now 5 millimeters. So, no, 14 millimeters. So that's 4, 8, 12, 13 and 14 millimeters. There you are. And now that's the first hole to be drilled, and the speed should be something like now it's about 600 revolutions per minute. Let's see. Okay. And I need to touch first it. That's the touch. And the hole should be 15 millimeters deep. I will be using power feed about 20 millimeters per minute. So let's go. So it will be 15 millimeters deep. So it should be, 10 turns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's it. That's the first hole. 15 millimeters deep. Yep. So the first hole is there. And now we will move to that direction. It should be 29 millimeters. 29 plus 5 is 34, is it? 34. Okay. Let's see. So 30. 34. There. Yeah. Let's see one more time that we are really there. 34 millimeters, and so is this. Okay. And now go to the touch point, like here, and from there on 10 turns. One, 2, 3, 4, 5, 6, 7, 8, 9, and final 10th. There you are. So that's our other hole. Now we just need to tap those. Yeah. So let's see, we need to have a tap follower, and I will change to that, and then I will tap those two holes. Is this hot? No. didn't even get hold. So this is actually 3.3 millimeter drill, and yeah, the depth was 15 millimeters. So next thing will be to use a M4 tap and tap the hole to up to the length. Yeah. Now this here is a M4 spiral flute tap, and yeah, I will actually fill the holes with cutting fluid. I hope. Well, there you are. Not exactly filled, but yeah. Okay, let's start and hope it doesn't break the tap. This is spiral flute, so it should be lifting the chips out from the hole. And so it does. I think it's there. I don't have the courage to put it any deeper than that. So then we need to go to the other one. First past the 0 like this, and then to 5 millimeters. The 0 is here, is it? No, the 4 is here. So 5 is there. Yep. And then raise the table again. And then, oh yeah. Let's do the other one. There you are. It's bottomed, this one. I should be able to get it out from there quite easily now. Pops. Yeah, there you are. I will take my so-called tap follower out. It's an automatic punch I have been using for this, and now these are tapped. Okie dokie. Now I have put this into the vise in a way that I can mill a small recess here on the top. It should be, well, let me see, 3 millimeters deep and 10 millimeters in diameter. I will do that with an end mill. And well, to place it correctly, the back jaw of this vise is already aligned with my scales, but unfortunately X direction is not. So I need to adjust it a little bit down maybe. So yeah, let's see now. This is easy enough to do. It's there. Let's put this one into 0 here. The quartz scale. And then also the fine scale here. Okay. Now it's aligned. Now my scales are agreeing with the workpiece. So let's see now. I need to take this hammer away from here very carefully, not to break the needle here. It's super easy to break that one. There is a ceramic piece which is intended to break if you drop it, for example. Let's raise the table. This has a rapid feed. The faster you turn, the quicker it will rise. It's a rapid. Okay. Let's see now. Yeah. So first, the Y direction. It should be, let's see, 90.5 millimeters. 90.5. Go past the 0, and that's the 0, and then 90. So that's 10, 15, 16. There, that's 16. 3 more millimeters. So then it will be 19. Now it's 19.5. There you are. It should be in the middle. And now this one then. Let's put this at 0. There you are. And this one should be 53. 53. 52. First. That's 52. 53. Let's put the brake on. 53.75. Oh. That's 70 and 5. There you are. There you are. Okay. Now, and of course, because this milling machine has a lot of backslash, you need to be very, very careful to lock all the both X and Y directions when you are doing this kind of a thing. And so now it should be 5 millimeters. So actually what I will do now, I will zero the fine scale here. Like that. Yeah. And let's see now then. It should be quite high revolutions. 600 is okay. This is after all a carbide end mill. And this is manual feeding, so let's touch first. There you are. I will take half a millimeter at a time first. So that's half millimeter now. And then we go 5 millimeters. That direction. That's 4. That's 5. A little bit over. A little bit more over. And now back 5 millimeters, 0.5 more. And then back. Okay, and then 0.5 millimeters more. Okay. Like that. Zero 0.5 millimeters more. Okay. And this is now the last one. I'll take a little bit more on both sides so to make it clean. Like that. And then let's go this side. And same thing here. There you are. Well, the recess is now milled. It should be 3 millimeters deep and in suitable place. Yeah. Well, it certainly is there, that's for sure. Yeah. Okay. So this concludes this part. Let's see if we can do another part today. Okay, let's change this little insert into this holder. I have made it, and yeah, in the past, probably I have a link in the video. Just clean up it a little bit. And then just put the insert in its place. It's there. like that. Very simple thing to do. Just see that it tightens in the correct place. Like that. It should be there. Doesn't need to be too tight. Just so that it holds it in place. There you are. New insert in place. Well, I noticed that the oil level, which you can see here, is a little bit low at the moment. Actually, I really don't know how much oil is there, but better to be safe than, well, safe than sorry. So I'll add some oil into it. There is an oil filling hole here in the side. And then, actually, if you read this, this is not the oil I'm using, it is just in the bottle. The bottle is like that, but you shouldn't believe everything you can read. So, in this case, this is Vactra 2 oil. Let's put it like that, and now let's add some oil into there. We should see how the oil level rises there. Yeah, I think it was missing quite a bit actually. Okay, now it's probably full. Yeah, probably it's all the way full. I don't know whether that's a good idea or not. What it does, it will leak the oil now everywhere if it's too full. So, and then I just close this like that. There you are. Oil filled in. Next step is to start turning a workpiece. Yep. Well, the next workpiece will be the handle. It is something that goes here, that you can switch the blade to its operating position and then to the retracting position. And this handle is made out of mild steel, and here we have a suitable piece. And well, it should be turned down to 10 millimeters. Currently this one is 12 and it's a little bit too thick to this. Well, as the picture there is, which you probably can see somewhere here, is now, well, I have to turn it down to 10 millimeters and make the place for the thread at the other end, and then part it off and then make the radius on the other end. Well, that's about it. Despite one thing, there has to be two flats, which we will do in the milling machine. Well, now the first thing is to put it into the machine to a suitable length, and as the document says, it should be the final length 67 millimeters. So, well, let's put something more here. 70, maybe 70, and that more, like that. So let's see. Let's put it here. $70 and a little bit more. There you are. I believe that's enough. It's a lot of stick out. Yes, it is. It really is. And I really don't know whether I like this. But let's see how it wobbles. Well, it doesn't wobble too much. And because it's so much stick out, it will also flex under cutting. So light cuts. And now I will face it. And my method of facing is that I touch it with the blade and then I lock the carriage like that, and then I use the compound to feed it. Let's see now. Okay. I think we might want to have a little bit more speed here now. Yeah. Let's try something like 1200. Let's see how it looks like. Yeah, way better. I don't take heavy cuts, it's very, very light cuts. And it still tries to wreck my insert in the middle. I can feel how it has the force there. Let's see if it's already good. It's already good, okay. So now it's 12 millimeters, so next step I would like to adjust my carriage stop. So we will be going up to here, and this here, you cannot see it nowhere, but I have a carriage stop here, and I will adjust it so that it stops somewhere there now. And let's see. So at that point it should be minimum 69 millimeters. That's because we need to part it off. 69. Let's see, 69. Well, yeah, we have plenty of material there now. So let's see. I'll tighten this carriage stop one more time so that it really stops. And then I test it like this. And let's feed in a little bit more like that. Yep, it stops. You need to be really careful with this one, because if it doesn't stop, sometimes the forces are so great that it just overrides the stop, and then there you go. Let's see now. We need to touch it. Yep. And then I zero my scale here, and we need to peel off, well, 2 millimeters from the diameter. So let's take 0.5 millimeters in the first pass. Let's see how it does, how it looks. A little bit whistling, but other than that, it's all right. Yeah. Well, actually, you can medicate that one. Let's try. We have here a variable speed modulator. Yeah, it minimizes the whistle a little bit. As you can hear, it modulates the speed so that it goes up and down. You can make it go way more than this, but this is okay. Let's see what happens. It should go well. There you are. Now let's see. It should be now 11.5 millimeters. 11.5. Well, it's 2/100 of a millimeter under. Let it be, it's okay. So I can go on from here using this setting. So next 0.5 millimeter, and there we go. Let's measure it now. It should be, well, 11 millimeters exactly. Well, it's still 2/100 of a millimeter under. Well, it's okay. And the surface finish, wow, it's amazing. So, yeah. Okay, and now the next 0.5 millimeter here, like this, and then there you go. Okay, and now it should be, well, 10.5 millimeters, I believe. And the surface finish is still excellent, very good. 10.5 millimeters. Well, now it's only 1/100 of a millimeter shy, and well, yeah. If you would like to make a precision, a really precise cut here, I would use a dial indicator here somewhere to measure the travel, and that would give me the exact measurements. But now, well, the last cut, 0.5 millimeter, seemed to be a very good choice, and let's do it right away, yeah. Okay, should be quite exactly 10 millimeters now. Let's see. Couldn't be any better. It's really good. 10 millimeters, well, 5 microns under. So yeah, okay. It's a little bit hot. Okay, next step is to create here at the end 12 millimeters from the end should be turned down to 6 millimeters in diameter, because we are going to create an M6 thread there. And furthermore, it should be, let's see now. I have to loosen this, and this is really tight. And it should be tight. So now I go here and touch the end, put my, no, not that yet, but let's see now. I zero my travel indicator here, like that, and then I just go 12 millimeters. So that's 10, 11, 12. That's it. Yeah, and then I set my carriage stop at that place. And then we continue taking 0.5 millimeter cuts. That's the first 0.5 millimeter until we are in 6 millimeters there. Let's check that this really is tight now. It is. And I think we are ready to go. So down to 6. So let's see if it is. Well, yeah. I was lucky enough to compensate it correctly. So it's 6.5, so now it should become 6 millimeters quite exactly. Let's put it here. Now, yeah. That's the last pass now. Okay, now since we are there, I will feed a little bit with my compound, just a little bit, and then come back really carefully here, just to make that cut perfect. Yes. Okay, we are done with that, and now we should chamfer this end here and break that corner a little bit. Well, not too hard to do. Just change the tool here to something more convenient for that operation. It's not that, it is that. Yeah. I think we might need to slow down it a little bit, but let's see. It might not be necessary. The radius is so small here. And this is, okay. Okay, that's good. Well, it was not needed. That's for the thread. And then let's break the corner here. Okay, we need to get rid of that. It's a little bit on the way. Yep. Yeah. And this is just to break the corner, nothing more. There you are. It didn't break the corner. I think I will be using a file there. And now, let's see if I have a suitable file somewhere. Usually I do. This one's a good file. And yeah, one thing, people try to file these over that region, like this. That's, you have to learn how to hold this on your left hand, because it's much safer to do it from this side. So there is my safe corner. That's it. Now it's broke. Yeah, it's really nice. And the next thing is to put here something like this, and take this one away a little bit. Okay. Yep. I'm going to use a die for this operation. And, well, let's see now. Back gear here, like that. And what is this for is to hold this thing straight. Like that. Now it's holding it straight. And then I just turn a little bit first. Yeah. Let's put some cutting oil in there. Yep. And then turn it. Okay, now it is. Yeah, it's straight now. There you are. I think we don't need any more threads in there. Oh yeah. Done. Yeah. And the next step is to part it off. A very easy operation actually. Oh, this doesn't want to come off. very easily, but it comes. Okay. So next operation, parting it off. Yeah, let's part it off. Parting blade is here. Has to be tightened in place. Let's have some cutting oil in there. Yep. See that it squirts out. It does. And then, well, the next step is to measure it. It's a mistake here to have measuring it from the blade. I always measure it from the body here. So now, and now I reset this to 0, and then I can retract this away from there, and this will be 67 plus 2. That plus 2 is the width of the cutting blade. So 69 millimeters. So that's 0, 10, 20, 30, 40, 50, 60. 69 is there. There. And then we lock the carriage here, like that. And now, of course, you want to see that it has room to rotate there. It has. And then we need to catch the part. I have a catcher here somewhere. Yeah. A plastic tube goes like this. And yeah, this is cutting like this should be rotated backwards like this. And yeah. And this is really, really no drama at all. It's amazing how silently it cuts it. Now here you are. And it leaves a wonderful nibble at the end. This must be, of course, must be removed. Okay. So that's it. And the last step here, before going to milling machine, is to make a radius in this corner here. And that one we will be using a radius blade. Well, we need to get rid of this, of course. Well, and now, of course, it will mark this workpiece. I try not so that it wouldn't mark it, but it will actually. Well, not too bad. For this radius, it's better to have it very near the chuck, so it's there now. And then we of course need to change the tool for something more suitable, and the more suitable tool is this. This is a radius tool. It's not made by me, it's made by some really skilled guy. Let's see whether it is in the center height. That's really important here. It's not. I think that's the place. Yeah. And this one should be running really in slow revolution, so 180 maybe. Then I will take off the, let's see now how it looks like. Well, yeah, okay. Let's see. I think I will lock the carriage somewhere. Somewhere here. So then I can use these controls to get it done. Yeah. Okay. Let's start with this. This doesn't need to be like full round thing. All it needs to be is just round enough that you don't hurt yourself with it. I think we are there. I don't want to put any more roundness into it. It's there now. Yeah. Oh. There you are. Well, couldn't be any better, I think. Well, it's okay. Yeah. Now just the flats, and then we are done with this. So next step will be milling machine. Well, this thing here is an ER40 collet block I have made, and I have here 10 millimeter collet, and now the workpiece is attached into it. It's really tight at the moment, so I just put it here on the vise, such that it is actually so that the back side of this nut is actually touching the jaws. So then I just tighten it in place, and there we are, like that. Now the next step is to align this cutter, and this is really non-critical. I'm just looking for my glasses. There they are. Cannot see nothing without these. Okay, now I will roughly adjust this. I need to put. I put it in high gear. Yes, like that. So I will adjust it roughly to the, so that it's about, well, let's see now. I think that's about the correct place. And then I will just lock my x-axis here. Yep. And this will be actually manual feed. So I just turn this on. It slings a little bit oil, so therefore this cloth. Let's see now. I will raise the table until it touches. There you are. Now it touches. And then I zero my set scale here. And now, so it was 8 millimeters. The diameter of this one is 10 millimeters, and we should take away 1 millimeter each side, so it becomes 8 millimeters for the key, and it looks like it's in the correct place at the moment, by the way. So what I will do now, I will raise the table by 1 millimeter. There you are. And then we just do the milling, I believe. Yeah, let's go on with it. Okay, that's one. And then what I will do now, I will just turn it 180 degrees, this block. Like this. Put it in the same place, this way, and then tighten it there. And now we do the other side. And this is actually, couldn't be simpler than this. If I take an 8 millimeter wrench, this is an 8 millimeter wrench, and put it there, so it's exactly suitable for that. Yeah, okay. Well, that part is now ready. Just a little bit deburring, as you can see, it made a horrific burr. And after that, this handle is ready. Okay. So that's all about I will put in a video this time. Next time it will be something more. The other part for the handle, and also we start making the more accurate parts, which will be the logic, the brains of the operation, which are dealing with the eccentric and the moving parts, how to move them and how to lock the dovetail into place. So this will be in the next video, in the next episode. So, well, nevertheless, this is not the end of this video. There will be something that I found out during my trip in Australia, and it will be a thing called thrombolites. Yeah, thrombolites. So let's see what those are, why they are really important for us, and yeah. So after this, well, I will now say you see you later. Bye bye. Okay, so today we are here at whatever this is the place. I will tell it later on, and I will also show somewhere here a map where we are. But one thing here nearby are so-called thrombolites. those are very, very ancient bacteria and bacteria colonies which have been actually making our atmosphere breathable. They are the first organisms that are making photosynthesis, thus creating oxygen. And yeah, before that, the atmosphere was something like methane and carbon dioxide, not breathable at all. And now, well, as you can probably hear on the background, there is a sea rumbling on. I have a few shots from there, you can see here. And yeah, okay, but this is the first place where we can see that in the shoreline there are some thrombolites, but those are already dead. So sorry about those dead thrombolites. And yeah, and the next thing we shall see what we are looking for. But later on today we shall also see live thrombolites. But more of that later on. So now enjoy the scenery. What is the difference between stromatolites and bromatolites, the other type? The difference is that stromatolites make layers on top of rocks, and those thrombolites tend to cluster, make clots inside, so the stone, after they have been living there, is really porous. When stromatolites have been living there, it's solid. Okay, here we are. This is a little bit bigger lake. I will show this in the map. I really do not remember the name of the lake, nor the place where we are at, something like Huron or Heron or whatever Huron it was. I don't remember, but I will show it on the map. And well, this lake is not salty enough to have those thrombolites or stromatolites. It is too sweet for those. But we are aiming to another lake, which is a parallel lake of this one. It is between the ocean, the Indian Ocean, and this lake. It's a very, very narrow lake called Sifton Lake, I believe it was. And there we have the living thrombolites, probably the biggest colony of those in the world. At least it is the biggest one that is commonly known. So, yep. Okay, so here we are, the world's largest living colony of thrombolites. This is actually, I think this is a nature reservation area. It is strongly forbidden to go beyond these wooden bridges here, and these are studied by scientists, these thrombolites, which you can now probably see. I saw a picture you, and yeah, it's the whole area is here filled with those, and so is there also. So this is just a small portion of those thrombolites which are visible here. This is how the living or the ecosystem looked like in the very early Earth, when the life was just beginning. And yeah, so not very much stones. So yeah, but these are really important stones, as they produced all the oxygen. Almost all of it is produced by these cyanobacteria that are still living among us. Yeah. That was all about thrombolites. Thank you for watching.